Ignition sequence starts.
Good morning, and welcome to a view of the International Space Station Flight Control Room at NASA's Johnson Space Center in Houston. It's where a team of specialists is always on duty, keeping tabs on space station systems and working with the Expedition 63 crew members as they take care of science operations and station maintenance. Commander Chris Cassidy and his crewmates spent time this week demonstrating the habitability in space of the station's newest component, the SpaceX Crew Dragon spacecraft, and they monitored the undocking of a Russian cargo ship wrapping up its mission.
Houston Station on Space to Ground.
Welcome to Space to Ground. I'm Isidro Reyna. This week, a Russian cargo craft departed the International Space Station. The Progress 74 resupply ship was packed with trash and obsolete gear before it undocked from the station on July the 8th. The vehicle had been attached to the orbiting laboratory since December 9, 2019, bringing nearly 3 tons of food, fuel, and supplies for the station's residents. After separating from the station, the Progress fired its deorbit engines over the South Pacific and burned up safely in the Earth's atmosphere. Progress 76, the next cargo ship to replenish the crew, is scheduled to launch on July the 23rd and dock to the station just 2 orbits later. The Expedition 63 crew stayed busy this week conducting a habitability test of the Crew Dragon Endeavour. Doug Hurley and Bob Bankin performed a series of tests to verify Crew Dragon's features and functions while in orbit around Earth, including opening and closing the hatch, operating Dragon's waste system, donning their spacesuits, and moving cargo back into the vehicle. They were also joined by 2 more crew members to test Dragon's sleeping configuration to assess the spacecraft and determine what improvements could be made for future crews. The Demo 2 mission is the final major step before NASA's Commercial Crew Program certifies Crew Dragon for operational, long-duration missions to the space station. This certification and regular operation of Crew Dragon will enable NASA to continue the important research and technology investigations taking place on board the station, which benefits people on Earth and lays the groundwork for future exploration of the Moon and Mars. This week's question comes from Chris. He wants to know how many people the International Space Station can hold at any given time. The space station has been continuously occupied since November 2000. International crews up to 6 people have lived and worked on the station, but with the dawn of the Commercial Crew Program, that total will likely increase. The living and working space in the station is larger than a 6-bedroom house, and for now has 6 sleeping quarters, 2 bathrooms, a gym, and a 360-degree view bay window. The record for the largest population on station was set in 2009, when 13 astronauts and cosmonauts were on board. Keep sending in your questions using the hashtag AskNASA. We'll see you next week.
One, zero. Ignition.
You witnessed history with the first crewed launch and docking of the SpaceX Crew Dragon, but you didn't see the flurry of activity on board the International Space Station. Until now. Take a look as Expedition 63 Commander Chris Cassidy and his crewmates set up to document the DM-2 launch and see their point of view as the new American spacecraft docked to the station and delivered new crew members.
Okay, it's a historic day for our nation and the International Space Program, really. And it's the second attempt for Bob and Doug to launch on the Crew Dragon. And behind this hatch is where they will dock tomorrow. I wanted to talk a little bit about this very special flag right here. This flag was first flown on STS-1 with John Young and Bob Crippen. It was then later flown at the end of the Space Shuttle program on STS-135, of which Doug happened to be a crew member on that mission as well. STS-135 brought this flag to the space station with the intent that it would be returned with the return of the first commercial crew rocket that would launch from Florida. So at the conclusion of their stay on board the space station with us, they will return this flag with them and kind of complete the journey, if you will, down in Florida right now, they had the go no go for launch. Historic day. I'm super honored and excited to be part of it in a small way, and greet these guys when they come through the hatch. It means a lot to everybody. It means a lot to a lot of people. A lot of hard work. All right. All the best from Node 2 of the International Space Station, the very forward part of our ship. This is the bow, so to speak, and go Dragon.
Count. Take it away, John.
So it's SpaceX launch day.
Minus 13 minutes, 30 seconds.
You heard
continuing
him.
to
T
count
minus
down.
13 minutes, 30 seconds, counting
We're
down.
continuing to load fuel onto the first stage. That should finish up.
Pretty
in,
cool.
Second stage.
I think they just said the last big go no go for weather's at 7 minutes, so that's like 6 minutes from
into
now.
the storage vessels on the first and second stage. Gets us just like we do with liquid oxygen, the maximum amount into the storage.
We've
volume
got
so that we can
cameras
get the most
going in
performance
multiple
out of the
windows.
vehicle.
Yvonne has a camera in there. I have a
Right now,
camera
we
in
are in a
there.
fairly quiet
We've got a
state
camera
on
in the
vehicle. Now
wharf
pump, continue to
window.
put the
So
propellant in
here's
minus
Yvonne
10
right now,
minutes when they talk to the
and
crew.
he's setting
We'll
up
listen for that.
a camera,
But
and
at
we're
the
trying to
moment,
figure out the
everything's
best angles
continuing to look
to
good.
get pictures. 10 minutes to go, man.
SpaceX Dragon displays are configured for launch.
Display's
Copy.
configured for launch.
Bob,
Awesome.
Doug, on behalf of the entire SpaceX team, it's been a huge honor to help you get ready for today's historic mission.
Thanks, Jay. It is absolutely our honor to be part of this huge effort to get the United States back in the launch business. We'll talk to you for more, but thank you.
Get some, Doug and Bob. Here we go.
And then the fuel load will complete.
So close. 350.
They have
In
insight
1 minute, we're going
directly
directly
into
over
Dragon and
KSC.
Falcon 9. They're able to see where their
I'm
fuel
gonna
loading
go.
is at, how everything's progressing down, what they count.
AFTS final setup started.
Going to get the picture in the warp.
3.5 minutes for launch.
And the strongback is now reclining away from the Falcon 9.
Great pictures right over the pad. Come on.
Dragon, SpaceX, go for launch.
Yeah!
SpaceX Dragon, we're go for launch. Let's light this candle.
T-minus 30 seconds.
Here we go. Get it, get it, get it.
Stage 1 tanks pressing for flight.
T-minus 15 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Ignition. Liftoff of the Falcon 9 and Crew Dragon. Go NASA.
Yeah!
SpaceX. Godspeed, Bob and Doug.
America has launched. So rises a new era of American spaceflight, and with it the ambitions of a new generation continuing to dream. 20 seconds into flight, stage 1 propulsion
Here we
is
go.
nominal.
Going to the cupola.
Plus 30 seconds into this historic mission.
It'll be the second engine cut off. We'll be looking for that stage 1 landing burn shortly after.
Is that pressurized?
Mm-hmm.
Actually, just within a few seconds of each other.
No, is it pressurized?
And it's right at about 12 minutes
Oh,
when
yes.
Dragon will separate. Looks like we saw a 0G indicator floating around there.
They do ensure that the vehicle is
Okay.
not spinning and is in good
We're gonna have 2 new
condition
crewmates here
before we
tomorrow.
separate.
Well, a few things have to happen
The
between now and then,
Everseas
but
does small
that was a big
attitude
thing.
maneuver using cold gas thrusters.
Well, it's DM2 docking morning. Just woke up and gotta hurry up and get my exercise in because it's a busy day with other stuff. But super exciting. What an awesome day it was yesterday to watch that launch go. Knowing that they're coming here made it even more special. All right, gotta go knock out my exercise. They're holding right at 200 meters right now. They're just wrapping up manual flight test objectives, and then in a short little bit we'll start into approach 2. And I've got this procedure here which we're following along. Right now we're in block Charlie, monitoring Dragon manual flight test. The vehicle mode is manual flight. There they are.
We copy and concur.
And that's 200 meters from the center line of the space station. And as soon as I get inside of 200 meters here, I'm going to switch to a different reference point, and we'll reference from the docking port.
We do plan to hold briefly at waypoint 2, so reminder that crew visors down are not required until the ground is preparing to commence the final approach.
Chris, you can monitor now for step 2. That's step 2 and 1.104 Crew Dragon approach and retreat monitor.
Copy. Step 2 alert. Steps 3 and 4 is complete. Crew on the International Space Station is ready for docking. All right, 20 meters, here we go.
Dragon copies all on the big loop. Go for docking.
Go for docking. That's a good one.
3 and 4 and 1.104 Crew Dragon approach and retreat monitor.
Copy. Steps 3 and 4.
SpaceX Dragon on the big loop. Our visors are down.
Visors down. They are.
Copy, visors down.
They're sitting right there, 20 meters from the docking port. One more view.
SpaceX and Station Dragon on the big loop. We are inbound from approach 2.
Yeah, I have all this grammaticus now.
Okay, in this time we should be in.
Yeah, полотника стула.
That's okay.
Yeah, by here.
By here, okay.
16:30-40. It takes a long time for the hooks.
I was so nice pictures.
I got some. What? Oh, wrong camera.
I got some.
Dragon SpaceX docking sequence is complete.
SpaceX Dragon, we copy docking complete. Just like to say that it's been a real honor to be just a small part of this 9-year endeavor since the last time the United States spaceship has docked with the International Space Station.
Dragon arriving. The crew of Expedition 63 is honored to welcome Dragon and the commercial crew program to welcome aboard the International Space Station. Bob and Doug, glad to have you as part of the crew. Well done. Bravo Zulu.
Never happy. Thank you, Chris.
We have a Dragon.
Yeah. Okay.
You got it? Yeah. Hello.
Hello, how are you?
Doing great. How was your night of sleep?
Pretty good. It wasn't too bad.
Yeah. Go in. Look. Смотри. Sounds like go for hatch opening. Here comes the handle. Here we go! Wow, it's quiet. You can see the mechanisms rotating. Clicks, they're at the end of the travel. What's up, big dogs? How you doing? That's a smooth hatch, man. We couldn't even hear the mechanisms moving.
We didn't even feel a dock.
We have Bob Behnken from SpaceX Demo 2 mission entering the International Space Station, followed by Doug Hurley.
You could go online and read about Chris Cassidy's educational and military background and his history as a NASA astronaut. But you never really know someone, do you? Until you know things like their favorite musical instrument or the things they hope to be remembered for. Well, Cassidy shed some light on those things and more as the clock counted down to his third trip to space.
The clock has started. Roger.
What is your favorite season?
Fall.
What's your favorite constellation?
Orion.
Favorite musical instrument?
The viola.
The viola?
Only because my kids played it.
Morning or night person?
Morning.
One thing you're afraid of?
Screwing up on a space mission.
One thing you have in the refrigerator at all times?
Pesto.
What's your favorite book?
The Count of Monte Cristo.
Favorite movie?
Saving Private Ryan.
Favorite dance move?
Sprinkler.
What's your favorite color?
Navy blue.
Guilty pleasure?
Eating ice cream.
The accomplishment you are most proud of?
Being the honor graduate of SEAL training.
The next item on your space bucket list?
Welcoming one of the commercial crews on board the space station.
Advice that you would give to younger you?
Communicate more often.
Who inspires you?
Anybody that does unsolicited, unselfish acts.
What would you like to be remembered for?
Having the greatest NBA three-point percentage.
The structure of the International Space Station relies on a series of trusses engineered to withstand the different forces the station may encounter in low Earth orbit. In this demonstration video, astronaut Ricky Arnold explains the significance of these resilient structures and the forces they're up against in microgravity.
Hey there, I'm NASA astronaut Ricky Arnold. Welcome aboard the International Space Station. Today we're going to talk about the Space Station Truss. The truss segment is just about 100 meters from side to side.
A truss is a segment or part of the whole integrated truss structure. The trusses are used to support the 16 solar array panels, which provide energy for us, and radiators which get rid of excess heat that builds up inside the space station. The design of the truss involves triangles and beams, which can be seen on Earth in structures like bridges. Why triangles? Well, this is because of their unique geometric properties, their methods of transferring loads, and their spatial openness. Triangles are more rigid than rectangular shapes because they have fewer joints. The larger number of joints in a shape, the more prone that shape is to being impacted by shear forces.
What I'd like to talk a little bit about today is some of the forces that can act upon the truss. Well, the first force I want to talk about is compression force. And compression force is just like it sounds, two things coming together. So if we apply a compression force to the truss, what do you think is going to happen? Well, let me go ahead and do it. And you can see right here where the truss would bend. What do you think the opposite force of compression is? Yeah, it's going to be right. It's going to be pulling apart. We call that a tension force. And a tension force is what's going to help maybe even rigidize the truss segment, but it also could potentially pull it apart. I'm not going to pull apart this tape measure because we probably need it later for some work we have to do. Now, if you look carefully, this next force I want to talk about is basically kind of like a twisting force, and we call it torsion. And even when I just let go of the tape measure, you can see it will actually start to happen a little bit. You can start to see, because the center of mass is actually right here, where most of the tape measure is located, and when I let it go, the tape measure itself starts to twist just a little bit. Finally, the fourth force that can act along a truss segment is that can occur at a single point where two opposing forces work on a single point along the truss, just like they can upon the Earth's surface. Think about some earthquakes. You can have a plate that is, or along a fault line where one side of the fault line is moving upward or being forced upward while the other side is moving downward. And that force in one point in opposite directions is called a shear force. And we can also have that happen on the truss segment. Something like this. One thing to think about, where do these forces come from? One force, even though we're up here largely out of the Earth's atmosphere, we do still have drag with the Earth's atmosphere, which can impart loads on or impart a force on the truss segment. Another, I already hinted at earlier, is crew working inside. We're up here, we're exercising, we're moving really heavy pieces of equipment around. So we have an amazing engineering team on the ground, and we have specific disciplines that their job is to monitor all the forces imparted upon the International Space Station. They keep track of all those various forces I talked about and where they could be coming from, the atmosphere, visiting vehicles, or even things that the crew are doing inside the space station, and to make sure that those forces aren't significant enough to cause any damage to this wonderful laboratory and living space we have up here in low Earth orbit. Thanks so much for joining me today. We'll see you next time. So long.
Project Artemis, NASA's effort to return astronauts to the moon by 2024, has scientists excited about being able to use the water that already exists on the moon to support a sustainable program of exploration. Now, the presence of water on the moon is a relatively recent discovery, and one that opens up exciting possibilities for the future, while sparking some questions about where that water came from.
Exploring the presence of water on the moon. I'm Jim Green, NASA's chief scientist, and this is Science at NASA.
We are going to the moon.
As NASA prepares to return to the moon, one of the many exciting opportunities scientists are preparing for is the ability to use the water that exists there to support human exploration. The presence of water has been a relatively recent discovery, opening up many exciting possibilities for future exploration and just as many questions about the water's origins. In the late 1990s, NASA's Lunar Prospector mission found extra hydrogen at the poles. And where there's hydrogen, there might be water. Enter the L-CROSS mission, designed to determine the type and amount of hydrogen that might be present just below the moon's polar regions. Tony Colipri is a planetary scientist at NASA's Ames Research Center and was the principal investigator for the L-CROSS mission.
To determine the form of hydrogen at the poles, we needed a way to access material below the moon's surface. So we carried a piece of the Atlas rocket we launched on all the way to the moon and directed it into one of the large, permanently shadowed craters near the South Pole, which caused a plume of dust and debris to shoot upwards. We had a probe with 9 different measuring instruments following the plume's 10-mile or 16-kilometer upward trajectory. the Lunar Reconnaissance Orbiter spacecraft was also making observations of the plume while mapping the lunar surface from its orbit around the moon. The lunar dirt in the plume hadn't seen the sun in over 2 billion years. In the sunlight, among other metals and gases, we found water, about 5% by weight.
Now we know there's water on the moon.
Research scientist Jen Hellman is also at Ames. She explains why the discovery is much more than just a scientific curiosity.
Ultimately, I believe we'll be living on the moon for extended periods of time, so we need to take advantage of whatever resources we can find there. Water is H2O, a combination of hydrogen and oxygen, and we can break it apart. So now we have a source of hydrogen and oxygen that may be able to be used for rocket fuel, as well as a source of oxygen for breathing. Water on the moon gives you a new paradigm for future space exploration. Very exciting.
In the 10 years since the L-Cross mission, we have continued to study water at the lunar poles from orbit with instruments on several missions. But we still have lots of questions. Where, for instance, did the water come from? Some believe that the water in other volatiles could be remnants of comets and asteroid impacts over billions of years. Others point to recent meteoric showers that can be seen producing water vapor. And where exactly is the water? We've confirmed that water exists in the Cabeus crater near the moon's south pole, where the L-Cross impact occurred. But how plentiful is it? And can we expect to find it in other super cold regions?
We won't be able to answer any of these questions with certainty until we visit the South Pole with robots and astronauts.
Through the Artemis program, NASA is planning to do just that. Thirsting for more information about the changing science of the moon? Visit science.nasa.gov.
If you'd like to get another look at any of the stories we feature today, go to YouTube and Facebook, right there at those addresses, and look around. Take a peek at the other cool stuff you'll find about NASA and America's human spaceflight program. And if you're interested in good conversation about human spaceflight and space exploration, check out Houston, We Have a Podcast. It's where we talk to folks about their work in all aspects of space exploration, including the making of podcasts about space exploration. To mark the 3rd anniversary of the podcast, today Gary Jordan pulls the whole production team in front of the microphones to talk about their favorite episodes of Year 3. Go to nasa.gov/podcasts for this week's episode. It's where you find all the previous episodes too, plus the full library of all the NASA podcasts, all of which you can also listen to on Apple Podcasts, Google Podcasts, and SoundCloud.